All right, that means I can start, right? All right. Thank you very much for the invitation. It's my pleasure to be here. My name is Tivadar. Two things I want to tell you right before we get started. My children are playing Minecraft in the next room. So if you hear sudden screaming and shouting, it's because they are, I don't know, having an argument over some Minecraft resources or something. Second one, I caught a cold this week, so I might interrupt my talk sometimes briefly with some coughing issues and whatnot. Hopefully this will not happen. Again, as Felipe said, this will be an interactive talk, which means that whenever you want to ask me a question, just let me know. I will try to keep up with the chat. Okay, let's start with the presentation right now. Hey, was I muted the whole time?
No. I accidentally clicked on you. I was trying to pin you. That's why. I just spotlighted for everyone. Sorry about that.
All right, no worries. So yeah, just a quick introduction. Who am I? What am I doing? Whatnot. So my name is Tivadar Danka. I'm from Hungary, which is a small Eastern European country. Probably has fewer inhabitants than New York or Los Angeles. It's like a country of 10 million people. So it's a small country. I'm still living there. This is my home. What you might know me about is my book called Mathematics of Machine Learning. This is the book in my hand. And just a fun fact about me, I really love death metal. This is one of my favorite music genres, and whenever I can, I popularize death metal. But don't worry, I won't talk about it during this talk. So, what are my qualifications? So, by training, I'm a mathematician. I did my PhD in mathematics, finished around 10 years ago, and my topic was highly theoretical, not applied at all. It's in a branch called orthogonal polynomials. You might have heard about orthogonal polynomials. They are very beautiful mathematical objects, but not very interesting from a general application point of view, especially not in the context of machine learning and artificial intelligence. So what you see on one side of the screen was my main publication, my PhD thesis, and I'm pretty sure that no one read this except my advisor, even though I worked like around a year just to write this single paper. Also, a fun fact about me, my Erdős number is 2. You probably know Erdős number. Like there was a legendary Hungarian mathematician called Paul Erdős, and he has the Erdős number 0. If you have a joint publication with Erdős, then your Erdős number is 1. If you have a joint publication with someone whose Erdős number is 1, then your Erdős number is 2. So basically, that's your distance in the publication graph from Paul Erdős. But I'm Hungarian, so that's cheating because my advisor actually had a joint publication with Erdős. So basically, it's not that big of an achievement. How did I get in touch with machine learning from pure mathematics? So at the end of my PhD, I felt like I was spending a huge amount of my intellectual energy on subjects that are not that useful in the grand scheme of things. So even though I very much enjoyed pure mathematics and mathematical research, I knew that I'm probably wasting my energy because, let's be honest, they won't change the world. They won't solve big problems. If we do a publication together, that will make your Erdős number 3. Yeah, sure, your Erdős number will be 3, but good luck convincing me on writing another publication ever again, because I have like very, very bad experience with academic publishing, but that's a topic for another day. So after I finished with my mathematics PhD, I joined a computational biology research group. where we basically all we did was process microscopic images of cell cultures. So this was my first touch with machine learning. And even back when I started, we had no proper deep learning models, because basically that was around the time when convolutional networks first gained popularity. Like, models 10 years ago were much less powerful than now. So basically my job was to identify cells on images like this one you see here, and measure their phenotypical properties. And they are very useful, for instance, in drug research. Like, pharmaceutical companies use high throughput screens to measure how certain drug combinations affect cells. This is the first step in designing like drugs. Yeah, just a couple of fun facts, like what kind of tools I did not have when I started. We did not have high-level machine learning frameworks at all. Like, PyTorch was published in 2016, and that was like a huge leap for us, because before PyTorch, we only had like frameworks like TensorFlow. Maybe even some of us wrote or some of us wrote their own deep learning frameworks in NumPy. That was the first time which basically we could train models without having to worry about the very low level stuff. Back in 2025, we did not have transformers, we did not have large language models, we did not have agentic AI that we have right now. So it was a different time. It's interesting that now basically 100% of the code I write is coming from interactions with large language models. I will show you a couple of my later projects when I will highlight my vibe coded projects as well. And back in the day, when you had a question, you had to actually like Google, or God forbid, go to the library, to the university library, and like basically browse the table of contents for books manually. It was like I can't even recognize those times like from now, because they are very like bare bones. All right, so my first big project was an active learning library called Modal. I think my face cam is in the way, but you can you don't see it, but this repository in GitHub has 2,300 stars. So if I just turn my face cam off temporarily, you can see that. Basically, this is a library which focuses on human in the loop machine learning. The core problem was that labeling training data is very expensive, especially if the training data requires human expertise. For instance, if we worked with physicians, cell biologists, and they had to sit down in front of a computer and label microscopic images by hand, find each cell on their own, label the phenotypical properties and whatnot, and expert time is very valuable. So basically, there's a whole field of machine learning called active learning, which is built on the idea that you have a bunch of unlabeled data, and then you find the data points which would be the most informative for you if you had the labels, and then those data points are sent to the expert for labeling. And I think my library was the most popular active learning framework for Python. It was around 8 or 9 years ago. I don't maintain it, actually. Now that I have access to tools like Claude Code and ChatGPT Codex, I'm thinking about putting like a bot maintainer on the project. Okay, so after a while in 2019, I left academic research completely, because I was kind of disappointed in how the system works. It has couple of I don't know, downsides that I was unable to make peace with. So I found myself a job in the industry. It was in a small Austrian machine learning startup doing work in computer vision. I got fired 3 months later because I'm not a very easy person to work with. I don't treat my bosses well. Like, I'm usually don't respect authority. This is why I'm like a solo developer to the day. So after I was fired from my first and only academic job, sorry, first and only industrial job, I founded my own startup in 2020, couple of months before COVID hit. So we did every mistake possible. We spent years developing a product, or not years, but 1.5 year developing a product that no one really needed. So it crashed. I ended up basically spending all of my life savings. So around 2021, I had to start over everything from scratch. And in my country, this was peak COVID time. So it was really tough because the economy is still bad, but back then the economy was even worse. So just to like, forget about flushing $30,000 down the toilet, I started to post like mathematical explainers on Twitter, which is like Twitter was designed for microblogging. So upon first sight, this is a strange idea, but actually Twitter has a very good format called threads, where you add replies to your own tweets. And this format worked for me very well. And I became quite successful in a very short time. On the left side of the screen, you can see my very first successful Twitter thread, like almost 700 likes. For me, it was unimaginable back then. But of course, that time I had around 1,000 followers. So fast forward, yeah, this is my first viral Twitter thread. As I said, it's an explainer on the expected value, which is a concept in probability theory. So now, 5 years later, because I realized that I enjoy, writing educational content about mathematics and machine learning, like now my social media profiles have grown a lot. So I have around 90,000 followers on Twitter, even though this is a platform I use the least because it's not working out for me anymore. I also have like a quite big publication on Substack. It's a top science publication, over 40,000 subscribers. Actually, we just crossed 40,000 subscribers a couple of days ago. So it was quite big of a milestone. And the fun fact, this purple color you see in my presentation, and also in several of my other projects, it's coming from the famous mathematical constant E, which is Euler's number. So if you take the first 6 digits of Euler number and turn this into like a hex code, you get this beautiful purple shade. I discovered this by accident a couple of years ago, and I have been using this purple color ever since. Meanwhile, I wrote a book about mathematics of machine learning. It was released roughly a year ago. It was a big success. Like, it took me 4 years to write. Also contains around 700 pages of mathematics. I'm writing a sequel now, and ever since I started to sell the early access for this mathematics of machine learning book, I earned about $100,000 in revenue, which might sound good, but if you think about it, like if you divide it by 4 years, I mean, I got like a $25,000 on average every year, which is not that high of a salary, even in Eastern Europe where I live. Like, life used to be much cheaper here, but now it's also quite expensive. So financially speaking, writing a technical book is not a very good decision. Just like something for you to have in mind. However, I managed to build up quite a big audience. Like, combined, I have around 150,000 followers, which is like a good size. Like this is like I have quite a good distribution of my projects and contents. All right, my current projects. So right now I'm working on the sequel for this book. It's called Machine Learning from Zero, and I'm also developing a library to accompany the book, where basically in this library, this MLFZ library, you can find like very simple to understand reference implementations for machine learning algorithms. This is a machine learning or a computational graph framework by hand. It only uses NumPy, and it also has a quite detailed documentation. So if you want to basically build your own neural network library, I recommend you to take a look at this resource. Right now, this documentation and the whole library is completely free. One of my other projects is something which I just vibe coded in 2 weeks. This is my latest obsession. It's called Notebook Press. You can see a screenshot, but I decided to show this to you. Let me check. Yeah, this is like a tool which you can use to turn Jupyter notebooks into posts that can be published on social media with just a click. I love Jupyter notebooks because I think they are the best format to communicate technical ideas that are full of code and mathematics. But if you want to build an audience, like on Substack, for instance, the LaTeX support. I mean, if you don't know, LaTeX is the language where you can write mathematical formulas like this one here. This is the LaTeX source for this formula. I think I zoom in for you because it's too small. And if you just press the build button, and it builds you in a second like a post where the mathematical formulas and the code snippets are rendered into an image. So you can publish this right away on Substack, because this is optimized for Substack for you in this current beta version. Like you just press the copy button and then you paste it into a Substack editor. I actually built this for myself because my biggest problem is this. Like Substack editor is not very good for technical content. Okay, again, it's called Notebook Press, and you can check it at notebookpress.xyz. Feel free to hack it, because I'm currently doing a beta testing because I'm curious about the feature requests for feature requests for the application. I'm curious if any of you can hack my backend or whatever to see if there are any glaring security issues. So just feel free to have fun with it, but please let me know if you find any security issues or bugs or whatever. And fun fact, I 100% vibe coded this entire thing with OpenAI Codex. It's astonishing. Like it's extremely good at building complex projects. And because I had a previous web development experience, I knew what to ask. So my prompts were not like vague prompts, but I could explicitly tell the model what to implement. Like the model did not make any architectural decisions because I was the one who was sketching out the architecture to the LLM, to the AI agent. So I think these coding tools are really, really good, but you also should have some experience, because if you don't, then it will probably do something that resembles what you asked, but probably won't work in the way that is intended to. All right. Now, after this long 20 minutes of introduction, about the talk. So back when you asked me to give a talk, I was thinking about what would a good topic be. And basically, I realized that now that you have large language models and whatnot, and probably access to internet, learning technical skills is really easy for you. Best case scenario, you just prompt a deep research from ChatGPT, and then you use the result to turn it into a podcast with Notebook LM. I think that's the tool. It's built into Gemini. Basically, it builds you a podcast from whatever text you provide it to, and it's really enjoyable to listen. So this way, you can learn technical subjects on your way to school in the morning on the bus. Or I don't know what you used to go to school. Back in the day, I took the bus every day. So, however, what's not that good is learning how to make good choices, good career choices, good life choices. So that's why I decided to not talk about machine learning for you in this talk. Instead, I want to share a couple of things with you, a couple of lessons I wish I knew back in the day. Some lessons that I learned the hard way. For instance, I don't know, spending my life savings on a startup that failed anyway. First lesson, I think I tried to put the more important lessons first. First lesson is take more shots. Let me explain what I mean. So if you have any experience in probability theory, which I think you probably do because it's like around high schoolish subject. If you have a coin and you start to toss up the coin, eventually you will find the head. It will land on its head eventually. And if you want to calculate the probability that, for instance, if you toss the coin 10 times, there will be at least one heads. This is the formula here. So the probability of, I don't know, instead of success, you can think about this as probability of getting heads as the result of the coin toss. It's 1 minus the probability of heads, which is 0.5, and then you raise it to the power of n, which is your number of attempts. And in life, this p is like mostly based on luck and your skill also, but it's I call this parameter luck in the context of taking more shots in life. And this parameter n, the number of attempts, is what I call consistency. And this parameter, this n, you can increase it as much as you want. The p parameter, it has a strong upper bound. So let me explain even in an even more concrete manner. So a practical scenario, you have two choices. Choice number one, you invest 2 years of your life working on a single business idea that, statistically speaking, has a 10% chance of reaching success or profitability. This is like a hard and fast rule for startups, that 90% of startups fail, 10% of startups become successful. Or the second choice, you can ship a small project every month for 2 years. The downside is each of these small projects has only 1% chance of having success. So what would you choose? I think instinctively most people would choose option number one. However, if you calculate your chances of success with option number two, you can see that it's about 21%. So this is what I mean when I say take more shots. If you want to basically build a product or have good research ideas, publish papers, instead of finding like an idea that you work on for 2 years, you should accelerate your iteration loop. Basically, you have to build fast, ship fast, and if an idea doesn't work, then kill it as quickly as possible. So what happens if you ship one small project for 3 years? Your chances of success go up to 30%. What if you do it for 4 years? It's 38%. And if you do it for 5 years, it's almost 15%. I mean, 45% approximately. And this is like very good odds, much better than if you focus on a couple on a few but larger projects. If you follow social media, this is like an idea that is usually popularized by builders of our age, and this is why this formula has like a very good applications in life. Okay, so number 2, optimize for the right reward function. Again, let me explain. It sounds a bit abstract. So there's a legendary book titled Artificial Intelligence: A Modern Approach. It's an old book, so you might know something else as AI. I think it's more than 20 years old. In any case, it's a good book. And in this book, there's a story. I'm quite sure it's made up, but it still has like a really good lesson, really valuable lesson to teach. In this book, they tell about a vacuum cleaner bot who is rewarded after picking up dust or dirt from the floor. I think you also might have a vacuum cleaner bot at your home. They are these small flat objects around, and they just move around with respect to an algorithm, and they do some cleaning in the meanwhile. So as far as the story goes, this bot basically learned to bump into tables, knocking down the glasses on the table, which fell to the floor. It got shattered, and then it picked up the pieces after that, right? So this reward function caused like an unwanted behavior, and this phenomenon is something which you can observe in life all the time. One example is, if you are a social media company and if you optimize for engagement, then you end up with, like people endlessly scrolling the feeds, basically doing nothing valuable in the process, but you keep them engaged, right? You can show more advertisements to them. Or for instance, some companies optimize for money, but because of that, they leave a very negative impact on the environment. This is because their reward function is not correctly designed. So reward functions are very important in machine learning, but also very important in life. So what I would suggest to you, you are quite early in your journey, is to figure out a good reward function for you, and keep that in mind all the time whenever you are making those choices. For me personally, this reward function had basically 2 components. One is knowledge, and the other was like a positive impact on the world. This is why I don't have a lot of money, right? Because I'm still not a very rich person. However, I feel really good every time I wake up in the morning and I'm doing something, like I'm working, right? I feel good about my work. I feel good about my impact. And I think on the long run, this is more important than money, because money is just a tool for you to achieve, like results, maybe convenience, but that's not that's most important. Third point, it's like a bit closer to the machine learning and AI topic, and I would suggest you to not go all in on AI. In fact, I suggest you to not go all in on any technical trend. Here's why. Maybe you have seen this illustration before, but there's something called the Gartner hype cycle, which illustrates the evolution of technical trends with respect to time. Let me turn off my face cam, because again, it blocks an essential part of the presentation. All right, so here you have the time component. X-axis is the time, Y-axis is the hype. And this is something which every technical trend follows. For instance, AI follows this hype cycle. With agentic AI, we are right here at the top. Cryptocurrencies also follow this trend. Cryptocurrencies are somewhere here. So the whole hype cycle starts with an event called the technology trigger. For instance, OpenAI releases ChatGPT in 2022 November, and people start to play around with ChatGPT, and they realize that it's leaps and bounds better than any chatbot so far. So people start to have like inflated expectations, like large language models will bring artificial general intelligence. They will take over our jobs. We won't need to do any coding anymore. So after a short amount of time, we reach the peak of inflated expectations. This is the technical term for this peak in the Gartner hype cycle. I'm not just making this up. And as it goes, I mean, these inflated expectations usually burst, and then people start to get disappointed in the technology. For instance, in the context of large language models, we realize that they actually hallucinate, so they are factually incorrect most of the time. We have to solve a bunch of other problems with large language models. They are expensive to train, whatever. So we arrive to the valley of disillusion. For instance, if you follow the cryptocurrency news, this valley of disillusion with the cryptocurrency technology, I think it was the collapse of the biggest crypto exchange in the United States. I forgot its name, but this event happened a couple of years ago. And after people basically abandon the idea, after the people who follow trends abandon the idea, engineers swoop in and they can start doing really productive things with the technology. This is called plateau of productivity. Machine learning, I think, reached this plateau of productivity. Web development, it's already here. Agentic AI, large language models will soon reach this plateau. But right now we are somewhere at the height of the hype. And because of this, I mean, trends come and go, they fade in and fade out. And if you put all of your eggs in one basket, you can basically drop the basket and break all of your eggs. So what I would suggest to you is to identify the skills that are universal in tech. I have seen a couple of these hype cycles myself. You will see even more hype cycles because this hype cycle is accelerated by now. So the fundamentals will always be extremely valuable. So deep down, cryptocurrencies, web development, artificial intelligence, they are rooted in mathematics, algorithms, data structures, databases, programming, cybersecurity, and some other foundational skills. These are extremely important. If you are a master of even a small subset of these, you will be resilient to hypes and trends. No matter what the current hype wave is, you will have a job. You will be able to do good work, build nice things, because the foundation is what matters the most. Frameworks come and go. Mathematics and data structures, databases, they will remain for a long time. All right. Number 4. Let me know if I should stop the talk, because I have a couple of more slides. I think I will stop at like 10 minutes from now, so we will have time to ask questions.
Yep.
All right. Number 4, find people outside your bubble. So when I was a high school student, I realized that my average teacher spent their entire lives in the educational system. So a teacher, after a teacher is born, they spent, I don't know, from years 3 to 6 in kindergarten, then they go to elementary school right away, then they go to high school right away, then they go to the teacher training college or university, whatever. And after they obtain their degree, they go back to a school, elementary school, high school, university, whatever. Point is, they spend their entire lives in the educational system, which means that their personalities and their beliefs, their view of the world are aligned with this closed system, right? So whatever they tell you, they put that through a filter. They don't necessarily have relevant real life experience, because in their entire lives they spent in a bubble. I don't know about your exact circumstances. I don't know your teachers. I don't know what kind of schools you go to. This was my case when I was a high school student. So only apply this if this is relevant to you. But for me, it was certainly relevant, and I have seen this pattern since then everywhere. So if you take any research field, every field in tech, whatever, they tend to form a bubble, and these bubbles start to become like really counter selective, right? So they lose touch with what's happening outside the bubble, and this is not something which you want to experience. Always find people who are outside your bubble. So for instance, for my teachers back in high school, what mattered was obtaining good grades, participating in competitions, like in general, having like being a good guy. But in life, in real life, this is not what matters. I think what matters, what are the terms of success for me? I think it's solving hard problems and building useful things. I was not rewarded for these back in high school. Again, like probably we have huge cultural differences because you are living in United States, India, whatever. I'm coming from a small Eastern European country, and I went to school a couple of years after the collapse of the Soviet Union. Like Hungary used to be not a part of the Soviet Union, but it was part of the Eastern Bloc. So life was pretty different around here. And I'm this is where I get most of my experience. So I marked it with a green check mark to indicate that this is the things you should strive for. Speaking about going outside your bubble, all of my successful projects were inspired by people outside the field of research. The active learning library I wrote was inspired by doctors and life scientists, not machine learning engineers at all. I was having discussions with people who were annotating the data by hand, and this is how I got the idea to write this library. Or basically my entire social media presence was started by me as a mathematician trying to explain relevant and technical subjects to machine learning engineers, people outside of the mathematics bubble. This is how I got the idea for the book itself, which paid off really well. And I'm also quite proud of this book. Also, this project I'm working on, it was inspired by basically a media business. We have a question in the chat. How did your book get reach so many people? Is it because of your Twitter network? I would say my Twitter network is because of my content, right? So I grew my following by consistently putting out high quality content. I mean, I'm not able to judge my work, so I cannot tell you if it's high quality or not. What I can tell you is that I put an enormous amount of effort into always like writing the best posts that I could, and people started to like the posts. My Twitter following grew, and yeah, basically this is why the book reached so many people. By the time it released, I had around 100,000 followers on social media, so distribution was kind of good. I think what I did is called content marketing. That's a technical term, but I focused on value and quality, and basically growing my following was a side effect, so to speak. All right, I'm going to stop soon. Fifth one: choose a young mentor or advisor. Both of my advisors in mathematics were like senior professors, and even though I enjoyed working with them, I understand now that this was not a good choice, because if you join a group of an established scientist, like someone who's a big name, they will probably have zero time interacting with you, because they will be busy with media appearances, traveling to conferences. They will most likely have hundreds of postdocs and PhD students, and you will be like a drop in a bucket, so to speak. Also, they are probably they have like an established set of ideas, and it's really hard to convince them to work on new ideas, because they already made a career out of their old ideas, which back at the day were considered new, but now they are probably outdated. And they don't need you that much. You need them more than they need you, and this is not a good setup in life. On the other hand, young PIs, young advisors, young bosses, they are more likely to be on the lookout for talent. They have time to work with you. I did a PhD. It took me 3 years. I think I have met with my advisor no more than 20 times, which is not that much. I was working on research mostly by myself. And even though it made me a better researcher, it would be better if I had someone who was working alongside with me. Is PhD worth the effort? It's not a simple question. If I could change it, would I? No, I think I would do a PhD again. Probably not in mathematics, but in computer science. I mean, I think it depends on your personality. So I have the mind of a researcher. I am fond of abstract ideas. I like the pureness of mathematics, the pureness of research. But if your personality is different, then PhD might not be worth the effort for you. For instance, if you are more interested to building things than doing research, then I would advise you against a PhD. Actually, I would advise you sometime maybe even against like a college education. College education, the best thing in college education is the network you build, but all the knowledge you can get online for free mostly. And this especially applies for you in the United States, because there you have quite high tuition fees. For me, university education was free. Another question: what are the career prospects from research? Isn't it harder to sustain compared to industry jobs? I mean, research and academia is brutal. It's like a very distorted system. Essentially, the gap between a postdoctoral researcher and the principal investigator is really huge. It's like going from a junior software developer to the chief technical officer of a company. And because of this, it's like a very hard jump to make. It's very competitive. There are bad incentives. Like if you work in academia, you must publish a bunch of research papers, which is, again, I think they are optimizing for a bad reward function, because in academia you are rewarded for your scientific metrics. This is how you get funding, and this is not a good incentive system. How did you choose your PhD topic? I mean, I was young and naive and idealistic, and I was really enjoying theoretical mathematics. And I think I heard that my advisor is looking for a PhD student. I dove right into his topic, and it fascinated me so much that I ended up doing a PhD in it. Again, I had no interests in applications back then as a 20 years old mathematician. Now I think I'm more applications oriented. All right, so I think we have not that much time. I will answer one question in the chat. Did you do math Olympiad in high school? I don't really enjoy anything other than pure math. I did not. Like I was really, how to say, typical Eastern European high school student. So I spent I told this to Felipe before the talk. I spent most of my afternoons getting drunk on the playground next to our high school. I did not pay attention to my grades, studies, whatever. Like basically, I was partying, getting girlfriends, getting drunk, whatever. And I started to become interested in mathematics right at the end of high school. So my first couple of years of university, I had a huge amount of catching up to do. So I had to work maybe 3 times as hard as my peers, but I was really motivated. Another question: I love to learn a lot of maths, no matter what. So I really love to read your books sometimes. Thank you. What are the prerequisites for my book? I think the high school math should be enough. That was my goal, to explain relevant mathematics, even with a high school mathematics background.
Okay. Would you mind
Right.
if we ask some of the questions that we sent you?
Yes.
I think you answered some of them already. So I'll ask some of them that I don't think you've answered. So as you know, we create a lot of educational resources, and obviously you do a lot of work with creating books and creating other educational resources. And one of the largest challenges that we are facing is maintaining technical depth while catering to a large audience of students with significantly varying mathematical and technical backgrounds. So, what are some tricks that you use to help convey a complex topic in as few words as possible to your audience?
Yeah, I think what's most important is to always keep in mind your target audience. Like for instance, whenever I'm writing a piece of content for an engineer, I assume that they will be familiar with concepts from object-oriented programming. On the other hand, they won't be that familiar with mathematical concepts such as limits, integrals, sums, whatnot. So I think this is the number one thing. What I always keep in mind, like who am I speaking to? How to keep content relevant? That's a difficult question. I never really thought about that one. I am a kind of person who I don't want my audience to shape me. I want me to shape my audience, which might sound a bit of how to say, what's the right for it? Arrogant, but this is, trust me. I think it's a good thing. Basically, I have a bunch of things to say about mathematics, and I want to find the audience who is interested in that.
Great.
I
And
hope I
then
answered your question.
Oh, yeah. Then the other question is, so, going back to the hype curve, right? There's a lot of like new concepts in artificial intelligence that are currently going up that hype curve, and they're about to like come down, right? And we are
Yeah.
very interested in the organization. We want to really provide our organization members a diverse view of different concepts, right? So, for example, at the international level of the organization, we have like 7 committees covering ethics, computer vision, physics and machine learning, quantitative finance, computational biology, agentic AI, and then language modeling. So we sort of want to really introduce as many like concepts as possible to the members of those committees. And so, based on that hype curve, right, like what do you think are some new topics that are going to be growing over the next few years? And then what do you think are some topics that have reached that stage of productivity?
So I think the most important topics for the next couple of years will be neural network compression, distillation, whatever. It's already a very important subject. So as you might know, models like GPT, they are huge. They contain hundreds of billions of parameters. I don't know the exact number off the top of my head, but you can't just run it locally on your computer. You have to use the OpenAI API. And I think the future is model compression and model distillation. You will have to find a way to reduce the size of the models while maintaining high quality outputs. For me, that's the most interesting thing. I think this is kind of outside the hype curve I talked about, because this has never been such a hyped subject. Nevertheless, I think this will make or break AI companies in the future. And also hardware, like specialized hardware, is really important. For instance, there was a company called Grok who was working on specialized hardware for deep learning, and they have been just acquired by NVIDIA. They made their own not GPUs, but some other hardware accelerator designed for running like a large neural networks and whatnot. I think that's the most important research subject. Also, not necessarily AI ethics, but model interpretability, for instance, is very close to my heart, and it's not nearly talked about enough. Can you trust the output of an AI agent, for instance? How can you make sure an AI agent won't turn against you? I think this is called AI alignment. This will also be very important in the future. I think agentic AI is also going to be really important because, as far as I understand, the agentic AI frameworks are model agnostic. Not only model agnostic, but large language model agnostic, right? So if we can design like an entirely different architecture for the same prediction problem than large language models, then we will still have agentic AI frameworks. So it's kind of universal. So this will be important as well.
Great. Yeah, that's actually very close to some of the topics that we're researching. Yesterday we had a little like introduction, of like some of the organization members, and they're like, we're really interested in like representation learning, and then some of them were also really interested in like mechanistic interpretability, right? So like I think this is very close to home. And in fact, actually, the original sort of like goal of the organization was to do a project next summer, which would basically involve distilling a large language model so that it could run locally, right? And like making it like powerful enough so that like students across the world could use it for all sorts of like agentic projects that they'd like, right? Or whatever sort of artificial intelligence project that they'd like. And instead of having to pay, like $20 a month for an OpenAI API key, they would get it for free using our model, right? And now
Go
obviously
for it.
that's evolved into various different projects, but that was sort of like the original goal of what we were doing. So I thank you for sharing that. I think that's quite aligned with some of the stuff we're interested in doing.
I think after I finish with my next book, I will go more towards these model compression distillation subjects because this is what interests me the most.
I think there's one more question in the chat.
Can we get machine learning from zero for free when you publish it? I'm unable to say yes because of my contractual obligations, but you can just send me a message after the book is out, all right? And I will take care of it. Next question: what do you think about the hardware side of like AI, like embedded systems? I have very little experience in that, so I'm not the right person for that question. Unfortunately, hardware is my weak side. Okay, so initially you were interested in theoretical math portion, then how did you slowly move towards application-based stuff? Just interested to know, did you find it more interesting? But basically, I had a realization. So I don't like chess. And I don't understand why chess players and, for instance, chess grandmasters, chess world champions put so much energy into something which is basically irrelevant in the grand scheme of things. Sorry for chess fans out there. I think the world is not going to be a better place because of chess. And I realized that mathematics is exactly the same. Like, at least the theoretical part of mathematics that I was doing. Like, I was exerting a huge amount of intellectual energy to objects that only exists within my head and a couple of other senior professors' head. And then I started to basically look for topics where I could continue, which are relevant. So where my mathematical knowledge is useful, but they also make the world a better place. And this is how I end up doing this is how I ended up in a computational biology research group. All right.
So, I don't think there are any other questions.
Excuse me.
Oh wait, yeah, go
I also
ahead.
saw that you. Oh, I also saw that you stated your personality is INTJ in your X bio. Do you
Yes.
really have some strong faith in those personality?
Do I have what about my personality?
Like the strong faith?
What do you mean strong faith?
Like, do you strongly believe on those personality tests and stuff like that?
I mean, this is called Myers-Briggs Index. So it's relatively scientifically founded. It's like not a natural science. It's like more on the side of humanities, but it's like it has some scientifically backed research behind it. So I think these personality types, although it's not that simple, not everyone can be divided into one of 16 categories. I think the INTJ category describes me quite well. So when first time I completed such a personality test, I was blown away by the description it gave me. Like, I felt like the description they provided to me knows me better than I do myself. So I think the INTJ category is pretty accurate for me. But even with the Myers-Briggs Index, I mean, it measures your personality on a continuous scale. Because for instance, the first letter is introversion or extroversion, and it's not like a binary switch. It's like a number between 0 and 100, right? So even that system is even more complicated than the end result which you are presented with. But I do believe that this is a useful thing to do, like completing a personality questionnaire. Of course, you have to pay attention to complete the right questionnaire, not just some random Facebook quiz stuff you encounter. But if you can find like a good personality test, I think they can tell you a lot about yourself. Even HR people use these kinds of personality tests. I hope I answered your question.
Yeah, you did. Thank you. Also,
Thanks.
how many years did you work in your project Mod AL?
The active learning framework, you mean?
Yeah, that one.
I think I wrote the 90% of the code in 2 months. It was Christmas of 2016, and my mother was quite angry at me because I spent the entire Christmas next to my computer working on an open source project. And I think I worked on its maintenance for 1 more year, and then I abandoned the project, which is something I regret. We have another question. Does IQ matter? I think in the slides I was about to talk about the midwit meme, right? Again, it's like not a simple yes or no question. I think intelligence matters, but it's not the only thing that matters. Even intelligence have several different aspects. IQ is one of them. I think it's called the logical intelligence. This might not be the technical term, but you also have emotional intelligence. You also have other aspects, like for instance, your physical intelligence, your education, whatever, your lexical knowledge. There are a bunch of attributes that matter, and I think what you are looking for is like a T-shaped distribution of your attributes. Like you should put some effort into every one of them, but you should pick one that you focus on. And I think I won't say that intelligence matters. I think intelligence helps a lot. But if you lack intelligence, like I do, I don't consider myself an intelligent person. On the other hand, I'm really mentally strong. So whenever I have a goal in mind, I will carry out that goal no matter what. Like nothing can stop me. I can bang my head against a concrete wall hundreds of times, and I will win at the end. And this is one personality trait of mine that helped me more than intelligence. All right, so my answer to your question is like yes and no. Like you personally take more time to understand things, but all have 20 hours. How can I catch up to others? You shouldn't care about catching up to others, to be honest. It doesn't matter at all. It's like you have to let go of your ego, and you have to let go of your desire to dominate others. I understand this feeling perfectly. I wanted to be smarter than everyone, to be stronger than everyone, but this is the wrong reward function to optimize, so to speak. Right? I was talking about reward functions in the beginnings of this talk. Comparing to yourself to others will only set you up to disappointment, because there will be always someone who is smarter than you, someone who has more money than you, who is more luckier than you. But it doesn't matter, because you are not living their life, you are living your own life. Like you have to learn how to basically be kind to yourself, but also stay motivated to keep doing the work. I think I will show you one more slide. It's right at the end of my talk. It's titled "Push Yourself, not to break not break yourself." Sorry, just interrupt me anytime when you want me to stop. But I, like many other people, I used to compare myself to others a lot, and this led me to like a very serious burnout during my life. And my basically I fell into video game addiction. And this is a screenshot of my Steam account of a game called Destiny 2, which I played more than 2,500 hours because of my burnout, right? So you have to be kind to yourself. All right. Another question. Being a freshman, you are a person who usually gets easily fascinated and curious by diverse areas, and this gives you a hard time to choose. what do you want to do with your time and eventually with your career. I think, sorry, again, let me know if I'm overstaying my welcome, but I have a slide, I have a couple of slides about that. Like, what you describe to me is called the exploration versus exploitation dilemma. In general, there are two mistakes you can make in this regard. If you commit to a career path early enough, you don't have enough exploration. You haven't tried out enough things to know which is the one you want to spend most of your time with. The other mistake you can make is you jump around careers and topics too fast, right? Then you have enough exploration, but not enough exploitation. You don't take the time to go deep. And this mistake is solved by, these issues are solved by trying to strike a balance between exploration and exploitation. My personality tended to lean more towards exploration. Like you, I was interested in a bunch of subjects, and I was reading a different textbook every week, but I was only reading the first 20 or 30 pages of each textbook. As a freshman, it's perfectly fine. I think you don't have to worry about that. If you still feel this way 5 or 10 years from now, then you might start to consider actually picking something and sticking with this topic. In machine learning, there's a topic called Bayesian optimization. I think I even have like a small page in my machine learning framework about Bayesian optimization. This is about how to optimize functions that are really expensive to evaluate. And what you can find out after taking some time to understand Bayesian optimization is that the balance of exploration and exploitation is really important, because you optimize these expensive functions by taking random points in the sample space, and if you find something that is good enough, then you instead of trying to go far away from that point, you try to start looking for values around that point to see if there's a better value there. All right.
Great.
That's about it.
Thank you so much.
You are
This
welcome.
was an amazing meeting. We saw a lot of subtle machine learning references, especially with the reward functions, and I also saw the chain rule on I think the cover of your book, which was very nice. And thank you so much. I'm sure this proved very insightful for a lot of the organization members. We will be trying to post the recording of this video in 1 to 2 weeks. I have exams next week, so I will be quite busy, but I will try to post it by the end of or by Friday of the week of March 9th. And yeah, also, Tivadar, is it okay if I share your LinkedIn with everyone who's currently here?
Sure.
Thank you.
I might take a long time to answer.
That's okay.
As Felipe found out a couple of times.
Oh, wait, I think I'm trying to send it to the waiting room for some reason. Oh, there we go. Okay, perfect. All right. Thank you so much. Again, thanks so much for being here and speaking to us. This is very much appreciated. And yeah, I hope everything goes well with your Substack Jupyter Notebook application and then your new book as well. And I hope we can stay in contact. Thank you so much.
Yeah, thank you so much. It was
Thank you, everyone.
my pleasure to be here.
Bye. Thank you.
Bye.